What is Solana? Everybody here knows, okay, we built this really cool blockchain, fast, cheap, but there's another way that I kind of look at this. What are we building towards? That I wanted to just kind of share with folks. Where's my slide? There's three levels of, I'll say, abstraction that I look at when I talk with the team, when we think about, the growth and evolution of Solana. So at the most basic and I'll say factually correct level is Solana is a blockchain, right? We all know Solana at the L1, it's fast, cheap, decentralized, permissionless, all the great things that we know and love about Solana, the blockchain. But not everybody here is touching the blockchain on a day-to-day or engaging at a low level with the protocol, but you still are part of Solana. You're still engaged with Solana, right? So many Solana developers engage with Solana more as a technology platform, right? This is abstracted somewhat away from the blockchain itself. This is all of the tools, the applications, the infrastructure integrations that make Solana a viable place to build a product, build an application. And why do we do these things? What do we build on top of Solana? The platform is the Solana economy. All of these things are interrelated, but the nature of this fast and cheap blockchain that we built, the entire set of applications, products, companies, builders, investors, integrators that build unique things on top of it, all together form or are beginning to form a more cohesive economy. And depending on kind of who you are and what your expertise is, when you say, oh, I'm interested in Solana, you might mean any one of these three things. And I just wanted to sort of lay that out in sort of this abstract way, because I think it's important when we think about what does growth for Solana look like, that we sort of recognize what level of abstraction we're talking about. And all these things play together. So another way to look at this is it's a bit of, just like you have a development stack, you have a bit of an economic stack. Powering everything at the lowest level, you have infrastructure. You have the blockchain itself. And on top of that, you have companies and technologies that hopefully are profitable, attracting labor and talent, all of our developers, all of the resources, all of the super teams around the world, all of the Solana Bostons that get people together to get excited to build things, to ideally make money, make products, make things that are profitable, useful. And you start to see this cycle of labor and capital as we've seen more developers come into the space, we've seen more investment into the space, more investment based on this fast infrastructure enables more people to ideate on ever more kind of complex things as we're starting to see Solana's composable blockchain is leading to a composable economy. So what I want to do, sort of laying that sort of philosophical overview, is step through each of these, the blockchain, the tech platform, the economy, from this lens and just share a couple updates, kind of the way that I think about things, and also just some exciting updates from both the tech and sort of the economic side of things. So first and foremost is the blockchain itself. My background is as an engineer. I joined Solana almost 6 years ago as an early engineer at Solana Labs. And at the time, Solana wasn't even a blockchain. It was just an idea, let alone all of the great products and then the economics. So this is a fun story I like to tell. This is where Solana started. Solana, the blockchain. This was in one of our co-founders' basement outside of Denver, Colorado. And Anatoly basically gave me a company credit card and said, hey, go buy some computer parts. We need to figure out how to build a validator. We don't know what the hardware spec is. We don't know how fast this thing is going to run. And so I went on Newegg and Amazon and bought a bunch of parts and cool green LEDs. And this was it. This was the network. A couple months later, This was Solana's first data center install. This was pre-mainnet. Mainnet launched in early 2020. So in the summer of 2019, this rack here is in Denver, Colorado, where I'm currently based. These are the very first Solana production nodes. This was the entire network at Genesis. For those of you that have been around a while, the astute observer will recognize Trent.Sol in these photos, helping me rack the beginnings of the network. So this was 5 years ago. I think it's important to remember like how far we've come, right? This was the whole network 5 years ago. And today, this is the Solana network. We're on 6 continents. There are over 4,500 individual nodes and validators run by thousands of different people and organizations in countries and cities all over the world. This is just like tremendous growth. And I like to tell this story, one, because it's a fun trip down memory lane for me, but also I think it's important to remember like the timescales on which we're operating, right? Everything that you know about Solana today, or what you imagine, or all these great things you think about, or read the great and awful debates on Twitter about the future of this or the future of that, right? This thing didn't exist 5 years ago. So what can it be 5 years from today, or 10 years from today? So where are we going at the blockchain level? Something I've been talking about for a while, a lot of people are really excited about is, lost my image there, is FireDancer. FireDancer is a new validator for the Solana blockchain. So to date, we've basically had one validator and some forks of that same validator. So this was the software that we produced originally at Solana Labs, now being maintained by the team at Anza. This was the original Solana validator. This is what we launched the network with. Today, live in production, there's the Anza validator and, of course, the Jito validator. Jito and Anza validators share about 99% of the same code base, even though Jito is optimized for MEV and has some different behaviors, the code base is quite similar. FireDancer is a brand new validator to run the Solana protocol, to run the Solana blockchain. This is being built by an independent team coming out of Jump. They have some of the sharpest engineers, I think, in the entire industry, pointed at an incredible challenge of distributed computation. And these high-frequency trading firms like Jump are absolute masters at getting data around the world as fast as possible. That's their bread and butter. That's where traditionally these firms make so much of their money. And Solana's vision of propagating the global state machine, a blockchain at the speed of light, requires incredibly high-performance engineering. So FireDancer's been in development for a couple years. They made some big announcements recently at Breakpoint, if any of you guys were able to attend or watch the live stream. And this is also going to, over time, really improve the resiliency of the Solana network. Having 2 completely separate validator implementations, multiple teams, multiple code bases written in different languages, means that a bug in one client is extremely unlikely to be propagated to have a bug in the second client, which from a safety and resiliency standpoint is supremely important to Solana's long-term resilience. So what kind of performance are we looking at from Jump? The idea with Solana has always been that the network should be as fast and as cheap as the underlying hardware can go. And FireDancer is really helping bring the network to that, realize that potential. The code is written in C. It is hyper-optimized for the performance and the layout of the underlying hardware that it's running on. And in some of the early demos, and even in some of the production demos, FireDancer team has demonstrated over 1 million TPS of transaction ingestion across just 4 cores of the CPU running the validator. Now, this is the same hardware that is running today's production validators, right? This is not some supercomputer. If you're running a validator today and you choose at some point to run the FireDancer node, the capacity from removing so many of these bottlenecks in the existing implementation dramatically improves the potential performance of the individual nodes and therefore the overall network. So I'm going to just dive into this just a little bit deeper. So the way this is being rolled out, the way this is being built, because we've been talking about FireDancer for about 2 years, a Solana validator basically at a very coarse does 3 things. It brings packets in from the internet. It processes them in ingress and says, okay, are these any good? Are there transactions? Are they valid? It executes them in the runtime, the SVM, the Solana virtual machine, says, okay, what do these transactions do? How are they changed to the state? And then if it's the leader, it takes those transactions, packs it into a block, and sends that block out to the rest of the network. So it takes traffic in, runs transactions, sends a block out. In FireDancer, the team basically took these 3 functional chunks and broke it up into sort of discrete software components that they can build one at a time. So the Agave is the validator that is produced by the Anza team. So this is what Jito is based on. This is what runs most of the network today. Is written in Rust for the entire stack. The first version of FireDancer, what they're calling FireDancer v0, is called Frankendancer because it's a bit of a Frankenstein's monster. They rewrote all of the networking code in C, but they left Anza's runtime. So the thing that's actually doing the state updates, executing transactions, is still the original Rust code. And so the first version, that's Frankendancer. And then the full FireDancer, FireDancer v1, replaces all of the legacy code, all of it in C. So you have separate tool chains, separate compilers, no shared dependencies. And so this is basically the 2 main things that, for anybody who's following developments on the network, you're going to hear about Frankendancer and you're going to hear about FireDancer. And this is the distinction. And ripping out the SVM in the middle, that's the hardest part. Rewriting something so complex as the Solana virtual machine and saying, in my implementation versus their implementation, every single transaction, every byte, every packet that comes in, and every piece of a block that goes out needs to match to the exact bit 100.0% of the time, or we're going to have a divergence of the network. When a FireDancer validator and an Anza validator replay the same transaction and come to different conclusions. So getting these things bit exact is a tremendous engineering challenge and something that the FireDancer team is actively working on. So where do things stand today? Frankendancer, the easy one, and I say that somewhat facetiously, Frankendancer has been live on testnet for over a year. We actually announced this at Breakpoint last year. Some new exciting announcements. Frankendancer itself rolled out on mainnet with some early developer nodes. We are expecting the public validator operators to pick this up after Agave upgrades to 2.0 coming on the network, which should happen in the coming weeks. Full FireDancer, the big kahuna, is live on testnet, building blocks that are being confirmed by Anza validators and Jito validators. It's hard to understate how much of an accomplishment this is to have rebuilt the runtime and send it back to a legacy validator, and it says, yep, I recognize that. So this is super, super exciting. The final big milestone, bottom right, full FireDancer on mainnet. Hoping early next year, first half of 2025. This is really production sensitive, and so the team is working through a lot of security work, a lot of stress tests, stability tests, making sure, as I said, both validators come to the bit exact conclusion every single time they're going to replay a block. So this is super exciting. FireDancer is a huge project and probably the most significant update over the next year or so that we're going to see for Solana, the blockchain. So zooming back out, coming one level up the stack, blockchain is great, it's fast, it's cheap, FireDancer is going to make it even faster. Cool. If we don't have the ability to build awesome products and tools and enthusiastic people to build products and carry out their vision, it doesn't matter how fast or cheap your blockchain is. So one of the other things we focus on is making sure that Solana, the technology platform, is as robust as possible for a wide variety of use cases. So there's two things that I just want to call out here. There's obviously a ton of things happening in the Solana tech space, but two things that I just wanted to call out. The first is compression. This helps Solana scale. So everybody knows Solana transactions are very, very cheap. That's obviously the biggest thing we've talked about for a long time. So this is what we call execution economics. I want to execute a transaction. Great, it costs a fraction of a penny. Easy. But what if I want to store 1 million accounts on chain? I have an app, and I want to airdrop tokens to all my users. Well, reserving all of that space in the account actually costs quite a bit of money, and sometimes those state economics can be much more expensive than the transactions itself. To ask all of the validators to store thousands of copies all over the world, information about all your users' wallets and all their balances. So with account compression, this reduces state costs by several orders of magnitude by storing state in the form of transaction data in the ledger rather than in the active accounts database. So what does this look like for the developer experience and the cost? For general account compression, this is a token account, a program-derived address, or a PDA, we can see anywhere between 160 to 5,000x reduction in cost to create a single account. So when you are spending, 0.2 Sol to create 100 token accounts, that's whatever that is, that's $20 at today's price for 100 accounts for users. If you have 1 million users and you want to create new accounts for them, that's a lot of money for the developer, right? For the team that's trying to move some tokens around. Divide that cost by 5,000. And now with compressed accounts through something that was rolled out recently called ZK compression, this really makes scaling the uses for Solana that require a lot of accounts, which means lots of people, lots of users, much more accessible. Similarly, something we rolled out last year, compressed NFTs, uses a similar technology to bring the cost of minting NFTs down for anywhere between 4 and 5 orders of magnitude. So one can mint 1 billion NFTs 24,000 times cheaper than you could without compression. So anybody who wants to airdrop, their loyalty token or their access token for a platform that has 1 million users or 100 million users can run an experiment that costs 5 Sol or a couple $100 rather than running an experiment that costs a couple $1 million, right? So these are just a couple things that I think really help Solana scale up at the tech and application level. Another thing I wanted to talk about is token extensions. Token extensions, I think, are actually a game changer for what kind of business logic a company or a team or an individual developer can implement with minimal complexity. So token extensions is a new token standard for Solana. So historically, we've had traditional tokens or SPL tokens, and we have NFTs. The token extensions are a superset of anything you can do with an SPL token. So basically, any token that you've ever interacted with on Solana, Bonk, USDC, your favorite stablecoin, your favorite meme coin, these are all SPL tokens. Token extensions is a set of smart contracts that encompass all of the SPL token logic and allow the developer at the time of mint with a simple config file or a couple config files to add complex behaviors to what the token can or cannot do, or what behaviors are triggered when a user receives a token, transfers a token, or engages with that token. So a number of things, for example, transfer fees is a pretty simple one, right? If you have this token that I issue, and I said, okay, well, I run a business and this token represents, loyalty points at my store, right? One token equals $1 if you spend it at my store. But if you want to send those tokens to your friend, I'm going to charge a 2% transfer fee because I want you to spend that money at my store or on my storefront or in my retail shop. So I can use the transfer fee token extension to implement that logic without creating brand new smart contracts. Permanent delegate is another one that is pretty interesting and has actually been a little controversial, actually, which has kind of been interesting. Permanent delegate actually means that someone else actually owns the token, not the wallet that it's in. So you would not want this for your USDC or your Sol, right? To say, no, I believe in self-custody. I own the tokens that I own 100%. But what could you do with logic that says, hey, there's a token in your wallet, but someone else can actually revoke that? Well, if you have any sort of access token or a decentralized ID, a DID token, or a KYC token that says, hey, the issuer says you have access to this platform because you paid your dues, or you passed KYC, or you graduated from this university. But if for some reason some of these conditions are no longer true, we're going to revoke the token, right? You didn't pay your Netflix subscription this month, so we're going to revoke your Netflix NFT access token. So there's some really interesting logic you can do, and all of these things can be done at the base layer without building a lot of complex smart contracts. So it doesn't require Rust expertise or blockchain protocol expertise, and you can focus on the business and the product and the kind of experience you want to bring to your users. So all of these things, I think, really extend what Solana, the platform, can do. And what's been really, really exciting in this year, the renaissance of Solana, is how many people are actually doing it. This is part of the A16Z crypto State of Crypto report that just came out a couple weeks ago, showing that not only does Solana have the fastest growing interest in all crypto developer talent, we're also the #2 ecosystem only behind Ethereum. And that number is rapidly, rapidly growing. So Solana is really capturing the developer mindshare, both in terms of number of builders, but also number of projects that are getting started month over month, year over year. Recently just wrapped up Coliseum. I think Maddie's here is going to talk about Coliseum at some point. Recently wrapped up their Radar hackathon, which is Solana's global hackathon that's done once or twice, a couple times a year. We had 1,359 submissions from 64 countries around the world. These are not random little software projects. These are early stage product companies, people that want to build meaningful things on Solana. And the hackathons have been a tremendous catalyst for ongoing growth in the Solana ecosystem. And with the Radar hackathon being the largest to date, I only see this trend continuing. So this is super exciting. Did anybody here actually compete or submit anything for Radar? Right on. Thank you. Last thing I wanted to talk about before I run out of time, a couple updates from Solana, the economy. Now this is very broad term, so there's a few things that I just kind of wanted to drill down on. First thing is stablecoins. Everybody loves stablecoins. Well, some people love stablecoins. Solana has the most volume in the stablecoin market than any other blockchain. And we are seeing more and more stables pop up. Obviously, the big announcement a couple months ago was PayPal integrating and launching their own stablecoin, PYUSD, on Solana. This was a big announcement that came out at Breakpoint. And so PayPal's hundreds of millions of users across the globe are going to have access to PYUSD, to payments and transfers on PayPal and on Venmo in the coming months. So why stablecoins? Obviously, not volatile, not speculative, but there is a new use case that we've been thinking about and talking about recently that we're calling PayFi. Crypto has long sort of dreamed of itself of being the payments rail for the 21st century. And on-chain payments has been the gold standard. Even the Bitcoin white paper, right? The title is a peer-to-peer electronic payment system. So payments has been in the blood of the crypto ecosystem since 2008, since the Bitcoin white paper was written, and it is still a nascent use case. And I think the reason for this is, I think, a combination of where payments can be faster and cheaper and easier than where we've seen. So taking the sort of the financial experimentation and innovation that we've seen with DeFi, the creation of new protocols, DeFi is inherently based on buying one asset and selling another asset, right? Buying and sell, trading, swapping, leverage, perps, whatever you want to do. And I think that's great, but payments are based on send and receive. I want goods and services, and we're going to transact in money that we use, not a money or a money-like token that might go up 10x or down 99% when I just want to settle my bills. And so PayFi takes advantage of the time value of money, allowing for instant settlement to build a new set of financial primitives. So a couple quick examples. These are not fully baked products, just a few things that we've kind of kicked around. We all know about buy now, pay later. What about buy now, pay never? If I want to buy a coffee for $5 and I have some interest-bearing yielding token in a DeFi protocol like Camino, lending protocol, earning interest pays back over time, $5.50. I paid for my coffee without ever drawing down any of my principal or spending any money. There's also some very interesting and perhaps tricky tax implications for something like that. Not advice of any variety, just a thought. Similarly, on YouTube, if you're a YouTube creator or a social media creator, a lot of these like Mr. Beast or these big YouTube influencers, the production value for these videos is really, really high, and they only will get some of that payout after they've invested the capital and get their views, and then they get paid back. So something that could be done in creator monetization. I need $10,000 to produce a high-quality YouTube video. I get a $10,000 advance from a PayFi pool or a $9,000 advance. And as the views come in, the payments stream back to pay off the loan plus interest, and the remainder goes to the creator. Another example, accounts receivable. This comes really back to time value of money. I owe my supplier $100,000 for the purchase of, I don't know, some forklifts. And I owe the invoice in 30 days. And in those intervening 30 days, my supplier doesn't have the money. I still owe them the money. If they could get the money sooner, I'm going to sell the credit to a pool. I'm going to get $90,000 today or $100,000 in 30 days. I'll get the money today. I can reinvest that in my business. And then those who are providing liquidity in the payments pool, the customer pays off the debt back to the pool. These are just a couple examples, not fully fleshed out products. If you're interested in payments or economics or business, like maybe do something with that. Up to you. We have seen some very large, well-known companies that are building payments infrastructure and payments platforms on Solana. The real economy is based on people being able to buy goods and services, not just speculate and trade. PayPal, Stripe, Visa, Shopify, all of these have added support for Solana in the previous months or year. So I think the payment space is really, really exciting because this is ultimately going to power the Solana economy where people are buying things that they want to use, not just things that they want to speculate on. So that's why I think the payments space is really, really exciting. Very last thing I wanted to talk about, sort of different tangent here. When we think about growing economies, economies interact with other economies, right? We live in sort of a global world. The blockchains are permissionless, but we live in the physical world. We live in a state, in a country, and we have laws that we need to obey and governments to interact with. And so something else that has popped up recently, last thing I want to talk about, is this idea of a Solana economic zone. This is a new experiment. The first one recently wrapped up in Argentina in partnership with the government of Buenos Aires. And the idea with the Solana economic zone is, can the Solana economy, in this very abstract way, create a physical, tangible partnership between Solana's economy and that of a host country or host city or government of any size, and bring talent and capital and labor into these places to help boost not just Solana's economy, but also that of the host legislature or the host government. So the team that's building this, the Solana Economic Zone experiment or project, among others, the first one is called Forma City. As I said, they recently wrapped up their pop-up in Buenos Aires. I believe they have another couple of these planned for later 24, early 25. This is not the only way that this can happen. I think, with the Boston DAO team here saying, hey, this is, this is a Solana City conference, right? I want to see the Solana flag flying high above Boston and Cambridge and everywhere else. There was Island DAO recently in Thailand. We've got the build station in Germany, the port in Miami, and I really am excited to see both these more formal and informal sort of economic opportunity zones where people can get together in real life to build the digital economy powered by Solana. That I'm just really excited to see. So I appreciate everybody for whatever your role is in helping to build that. So thank you very much.